Yes, my dear friends, welcome all of you. So, my dear friends, if you belong to Telangana, so yes, this video is for you and it is important. Recently, Telangana government have released one notification about the AEE Assistant Environmental Engineering, and there is a total 19 post is there, and their tentative exam date is September, right? Before that, if you have remember, in the Andhra Pradesh also there was a short notice about the AEE examination, and their detailed notification will expect in the month of in around 15th of August we'll get the detailed notification. So already you have covered the material science in that batch also, right? If you talk about in the Telangana and Pradesh, so basically there are two paper, and paper 2 is common. This is totally common if you talk about either Andhra Pradesh or Telangana. Syllabus is totally same for the paper 2, and in the paper 2 one topic is that material science, or you can say the engineering material. So this is equally, syllabus is same, everything is same, especially in the paper 2, and this topic is basically from the paper 2, and one subject is there, material science. Already you have completed that material science, already you have completed in the paid batch of Andhra Pradesh AEE. As and here I have already the batch of Telangana state of the AEE also has been launched, and once you get the purchase the paid batch, instantly you will get the access of the earlier class that I have already completed in the Andhra Pradesh batch. That you will get their access of that class is also there. Along that, the some live class will be also there, right? So here, my dear friends, today I am going to discuss basically one topic of the engineering material, and that is what mechanical property of the material and testing of the material. That is most important, and in all the exam you can expect the question from that segment, right? So yes, it is important, and yeah, if you are from the Telangana, so yes, as I told you, you have a very good opportunity to work in your state, right? And if you see the question they are going to ask, basic question, they are not going to be touched the much more deeper things. Question is very basically they are going to ask the basics question, right? And that question is like that, it should be known to all the engineers. If you are engineer, so basics they will expect from you. So you don't need to go much more deeper, right? Here I am going to start today one topic I am going to deal here of the material science or engineering material, and that is what, my dear friends, that is basically we can see mechanical property and testing of material. That is one of the topic, and this particular topic, if you have remember, you already completed in your class 9th, 10th or BTech first year also. That is common to all. So here I will discuss about the mechanical property and testing of material, right? Sir, what do you mean by property? Anybody can tell me what do you mean by the property? After that, yes, I will test that property for any material have or not. So I will check. So what is property? Basically, property is that thing, my dear friends, which can be measured having some numerical value. Like if you talk about mass we can measure, so it will be property of the material. Temperature you can measure, it will be property of the material. Density you can measure, it will be the property of material. Stress you can measure, it will be the property of material, right? So these all things that you can measure comes under the property of the material, right? And obviously if we talk about mechanical, so yes, some force will act there, and the response of that force, how the property is going to behave, that basically have to be discussed there. And I have to be also you have to be checked, okay, how the property is going to be changed. That's why here we will discuss about the testing of materials, right? So property basically that is the character of the system that you can measure. Like, but don't think all the character of any body will be their property. Like if you talk about color is a character of the body, but it cannot be property because it cannot be measured. Same way you talk about the taste of the material, taste could be their characters, right? But that cannot be property because it cannot be measured. So always keep in mind, property is that thing which can be measured or having some numerical value. Already we discussed about mass, temperature, pressure, volume, density, right? Stress, that all can be measured, right? So that all are the property. So first, mechanical property means here you have to be read about the change in the property of the material when you are going to apply external force, external pressure. In the response of that, how the material is going to behave, that is your whole target to study in that particular subtopic of the mechanical property and testing of materials, right? So first thing here we can understand, first property that I am going to discuss, strength. So what do you mean by strength, my dear friends? You used to say that is my strength, right? You used to say, na, So that is my strength. So how you can define the strength? So here I have came with the diagram. So before just I am going to give you overview what thing I am going to be covered today. So all that content I have to be covered in that session. Plasticity, all the property, ductility, you talk about how the ductility is, malleability, right? And how we can understand malleability, creep, toughness, all that thing you have to be discussed in that session. What is hardness, how you can measure that, okay? Ductile, brittle material, all that all thing I am going to discuss, how they are going to failure mode, what is stiffness, okay? So all that things I am going to be discussed. Along that, my dear friends, at the end of the session I will see, okay, how much thing you have learned from that session, so that I will take some MCQ and you have to be answer that MCQ at the end of the session. First I will complete the question, after that complete the concept, then I will come to the question part, right? So that all are today thing that I am going to discuss with you, okay? So just I am going to be give you introduction, okay, what I am going to be cover in that session. That all thing I have to be covered here, and after that I will take their MCQ, okay, so that you can see, okay, how much you have learned, right? So okay, that all about the session. Let's start the story number first. What is strength? So simple, we can see here, strength is the ability of material to withstand applied load without failure. So what is strength? Strength is basically ability of material so that they can withstand the stress without any failure. It represents how much stress a material can bear before breaking or yielding. Depending upon the nature of load, strength is classified into tensile strength, resistance to pulling force, compressive strength, resistance to crushing force, and shear strength, basically resistance to sliding force. And yes, one torsional strength is there, resistance to twisting force. So material like steel exhibit high tensile strength, while material like you talk about concrete are strong in the compression. Strength is one of the most critical property in structures, and mechanical design is generally measured in megapascal. That all about the strength. So what is strength? Strength is basically that property of material, because of that it is capable to restrict their failure. They will not going to fail if you are going to be apply the load like that. This is called tensile force, right? So if they have sufficient strength, then they can bear that stress without any failure. That is tensile strength. Generally, same way, suppose instead of tensile you are going to apply the load like that, this is called compressive stress. So if the material have sufficient strength in the compression, they can bear that load without any failure, without any permanent deformation, right? So that is the thing about the strength, okay? So and strength, what will be the unit? It will be measured in the megapascal, okay, or even in the pascal, we can say. So here this is tensile strength. Here we can see, okay, compressive strength, you are going to be compressed. Basically compressive strength play major role in the case of crushing. What do you mean by the crushing? Crushing means breaking of any object in the form of pieces. Like this is one of the object and I am going to be crushed like that. So what is happening ultimately? The block is going to break in the different form of pieces. That is meaning of crushing. Like that here we can see compressive load you are going to apply on that object, and they have no sufficient compressive stress, then it will be broken down into the multiple pieces. That is called nothing but crushing. Crushing means it is going to broken in the multiple pieces. Tensile, this we can see. Shear strength, here we can see. And yes, twisting, you talk about, especially you talk about you have a shaft. So yes, they have sufficient torsional strength so that they can bear the torsional load. All that type of we can see there. Generally, my dear friends, if we talk about brittle material that are strong in the compression, right? That's why, my dear friends, in the making of the column, you are going to use the concrete, because column have to be take the compressive load, right? This is your column. You might have it in the bridges, right? And you are going to apply the compressive load. So they must have sufficient strong in the compression so that they can bear that load. Otherwise, there could be failure, something like that. It could be failure like that. Now, it could be failure like that. You might have seen that thing phenomena in the column. So for column, you have to select that type of material that must be strong in the compression, right? So that all about the thing of strength. Now elasticity. What do you mean by the elasticity? Yes, that is a very common thing usually used to say that people is very elastic in the nature. So what is the elastic? Elastic property of material by virtue of which it returns to original shape and size after removal of external load. So what is elasticity, my dear friends? Suppose this is one of the material and you are going to apply the load P. So once you apply the load P, what is happening? Body will deform something like that. It will deform like that, right? Now, if you are going to be remove the load, so what is happening? Body will try to recover their shape. So the property because of which that body will try to recover their original shape, that property is called is what? Elasticity. Getting? So if elasticity is high, meaning is that they can withstand the more tensile load, and once the load is going to be removed, they can recover their original shape. So here simple we can say elasticity is the property of material by virtue of which it returns to original shape and size after removal of external load. When material is subjected to stress within elastic limit, it undergoes deformation but regain its original dimension once the load is removed. This behavior is governed by obviously Hooke's law. Hooke's law I will discuss. It is proportional to strain. Here we can say the elasticity. Still law, Hooke's law, we have see stress is proportional to strain within what? Proportional limit, that is your rubber. We can see some steel and rubber, original shape is there, and Hooke's law is what, my defense, always keep in mind, stress is proportional to strain within elastic limit. Now we can from the other background, if you are not from the mechanical, you can confuse what is stress, sir, and what is strain. Strain you might have aware, change in length of any object with respect to their original length, right? Suppose that is the object and you are going to apply the load P. So what is happening? Their shape will be something like that. So this is called, you can say, the change in length. So what is strain? Change in length upon original length. Let's assume it was the original length. So that is called strain, right? Change in length upon original length. Okay, sir. But what is stress, sir? What is stress? My dear friends, suppose you have any object, okay? Any object you have, let's assume this is one of the objects. And in the world, if you talk about any object, so basically it is made by the combination of what, my dear friends? Atoms, molecules, or ions. You are going to apply the load P, and in the world, every body is made by the atoms, combination of atoms, molecules, ions, right? In the world, everybody, even you, my marker, my mobile phones, okay, my mic, my board, everything is made by the combination of what, my dear friends? Made by the combination of atoms, molecules, or ions. Now see, if you talk about any two atoms or molecules, so there is an interatomic force between these two, right? This is interatomic force, that is called molecular attraction, we can say. Because of these two forces, they are going to be close to each other. They are remains in the stable state. Now suppose you are going to apply the force P. So what is happening? What is happening? You want to disturb the distance between the atoms. Once you apply the load, that means you want to disturb the distance between any two atoms. You want to disturb their equilibrium position. Once you disturb their equilibrium position, it is a very natural thing, they will oppose it. And my dear friends, so when they will going to apply the load like that, what is happening? One resistance force will develop in the against of that. So here we can say, as you have applied the force P, the one resistance force will develop against of this, and this resistance force per unit area is called is what? Stress. So we can say P upon A, and obviously it will be, as you from the Newton third law, whatever force you are going to apply, same reaction will develop here also. So this is action, so this is the reaction, both will be equal. That's why you used to say, sir, stress is a internal resistance force, right? Why internally resistance has been developed? Because of the atomic forces, sir. Since there was an atom, it was in the stable condition. Once I apply the load, that means you have given the effort to unstabilize, or we can say destabilize their distances. So they will try to oppose that, and because of that, one internal resistance force is developed, and will get a stress. Getting or no? Suppose if no any extra internal force is going to be developed, you will not get any stress. Clear that point? So that is your stress. So keep in mind, it is proportional to within a proportional limit. Stress is proportional to strain in the proportional limit. Okay. Well, next is what? Plasticity. So what is plasticity? Plasticity is ability of material to undergo permanent deformation without rupture when subjected to strain beyond the elastic limit. So what is the plasticity, my dear friends? Plasticity is basically that property of material which try to continue, or which try to keep the body in the form of permanent deformation. Meaning is that, Suppose, sir, that is the body and I have applied the force P. Because of that, the body becomes something like that, sir. Let's assume. Now I remove the load. So because of the elasticity, they will try to come in the original state. But plasticity is what? Plasticity will try, they should remain in the same state. Plasticity will continue to maintain the whatever deformation has been takes place. They will try to maintain that deformation. So here clearly mentioned, plasticity is ability of material undergoes permanent deformation without rupture when subjected to stress beyond the elastic limit. Once material crosses the yield point, it does not return to original shape even after removal of load, and that is because of the plasticity, right? So suppose, let's assume I am going to draw a stress strain curve, right, and like that. So let's assume this is the elastic point, okay? So this strain is recovered. If you remove the point, if you remove the load before the elastic point, they will recover the shape. But suppose the deformation is there and I remove the external force, then we will not get the actual shape of the object, because they have go beyond the elastic limit. So there will be some permanent deformation, and high the plasticity, it will be more. And yes, this property is important in the case of forging, rolling, extrusion, that all are mechanical. People are well aware about the forging, rolling and extrusion. Forging is what, my dear friends? Forging means you have to be metal forming, especially you talk about, you have some metal and you have to be change their shape and size. Forging, you talk about nothing else is there, you have to be change their shape and size. You might have been seen in your blacksmith person, some thing is going to be heated, after that you are going to be hammer over that and it is getting some different types of shape whatever you require. So that is because of plasticity, because they have high plasticity. If a material have less plasticity and you will try to hammer that, it will be broken down, right? So here we can see plasticity in the diagram. Clearly it is visible to all of you, right or no? This is your yield point, right? This is your yield point and that is your plastic deformation. It is becoming what? Permanent deformation. You can see there. This is clay, very elastic, does not return to original shape. This is your mild steel and it comes in the plastic zone. So these two things is there, one is elastic region, another one is plastic. Next is what? Ductility. So what is the ductility, my dear friends? Simple. Come to the diagram part. Ductility is that property of material because of which, by virtue of which, they will capable to change, they will going to be changed in the form of wire. Generally your metal is ductile. So generally if you have to be make a wire, so you have to be select that type of material which is high ductile. If you talk about aluminum, copper, their wire you might have seen, because they have high ductility. So ductility is nothing but, my dear friends, simply we can say here, so ductility is ability of material to undergo significant plastic deformation before the fracture, particularly in the tension. It allows material to be drawn into wire without breaking, okay? And ductility commonly measured in terms of percentage elongation and reduction in the cross section. Obviously, if the length will increase, what is happening there? You can say the cross section, like way. Suppose that is the, so there, this is their cross section. If you apply the load, its length will increase, but cross section will what? Decreases. Right, highly ductile materials such as copper, aluminum provide a warning before the making them desirable in a structure application. Ductility is also important indicator of toughness and reliability. What is this? I will discuss. And my dear friends, sometimes they will ask which of the material is the highest ductile in the world. So always keep in mind gold. Gold is the highest ductile in the world. Whatever material known till now, highest ductility is gold. I will surprised to know, just take 1 gram of gold, 1 gram of gold, just take only 1 gram, already gold is very costly, and okay, I am not going to tell anything about the politics, but gold currently play major role in Indian politics, right? So just you have a 1 gram of gold and you will be capable to draw 2.4 kilometer of wire, just 1 gram, and by that they had that much amount of ductility, you could be capable to draw 2.4 kilometer of wire. Just take a 1 gram of gold. So that is ductility means capability to convert in the form of void. Now, what is malleability? Malleability is that mechanical property. In all that case, you are saying na stress is going to be applied, force is going to apply. That's why it all is called mechanical property. So malleability is what? Simple, we can see. Going to move here, you can see the malleability. This is one of the material you have, and you are going to be hammered at in the form of to convert in the form of sheet. So malleability is that property of material because of which it is capable to convert in the form of sheet. High the ductility, it will be easy to convert in the form of sheet. So if you have to be convert anything in the form of sheet, they must have high malleability. So how you can define the malleability, dear friends? How you can define the malleability? So here we can see malleability is the property by which material can deform into thin sheet under compressive force without cracking. It is closely related to ductility but differ in the type of stress applied. Ductility involves tensile force, malleability involves the compressive force. You are going to be compressed that. Material like gold, silver, aluminum are highly malleable and widely used in the sheet forming processes such as rolling and hammering. And another thing, keep in mind, my dear friends, which material is most malleable? Again, answer will be the gold. Gold will be the highest malleable material known till now. That means, sir, can I say all the ductile material is malleable? Yes, we can say all the ductile material is malleable. Having high ductility, there will be high malleability. But sir, can I say all the malleable is be ductile? No, you cannot say like that. You can say all ductile is malleable. Yes, that is right and 100% right. No condition is there. But if you can say, sir, is it right? All malleable will be ductile? No, that not necessary. If you see one example, PB lead, highly malleable, but it is not a ductile. It is considered as a brittle material. It is not as much of ductile. So that thing you have to be keep in mind. Here you have seen the malleability, right? You are going to convert in the form of sheet. You are going to hammer thick and you are getting the sheet. Example, as I have told you, gold, silver, aluminum, that all are the example of what, my dear friends. Okay, so now let us take next property, that is what? Toughness. So what is toughness? Toughness is that property of material because of which it are capable to store the energy before the fracture. So you know, my dear friends, that is any object, right? And you are going to apply the force F. So because of force F, let's assume their shape has been changed to something like that, and this is change in length is delta x. So I will ask, what will be the work done? So simple, we can say, sir, work done is force into displacement, sir. So this is the work done. Work done unit is what? Joule. Joule is what? Means energy. Right? Means what? Energy. So we can say to get that deformation, you have applied some energy. Yes, sir, I have applied. But where that energy has gone, you have applied that much amount of energy, okay. But where that energy has been gone? So yes, my dear friends, we can say that energy has been stored by the body, and that is nothing but that is called strain energy. And there are two parts of strain energy. One is called resilience, another one is toughness. So before the fracture, here we can say this is the object. If I am going to apply the force F, so and continuously I am going to apply the force, so one time you will reach when the body will get deformed. So whatever maximum amount of energy that body can absorb before the fracture, that amount of energy is called what? Toughness. Another one is resilience is also. So resilience is energy stored within the elastic limit. Means this is the one of the object. I have applied the force F because of the body have become something like that. Once I remove the load, what is happening? This is within the elastic limit. So once I remove the load, body will recover their shape. That means all the energy is going to be released, whatever has been stored by the body. So that is called resilience. Resilience is, we can say, recoverable. It can be recovered. But if we talk about toughness, so you cannot recover that. They are just going to be store all the energy before the fracture. So whatever amount of energy they are going to absorb before the fracture, that is called toughness. Right here we can see toughness, ability of material to absorb energy, plastically deform before the fracture. So both strength and ductility, total area under the stress strain curve, as you can see here, and after that it is going to fracture. So that is nothing but called is what? Toughness. Here also we can see glass is generally brittle material, right? It is going to be broken down in the form of pieces here. And especially you talk about strain energy. So strain energy play major role, my dear friends, especially when you talk about the load is impact. What is the meaning of impact? Impact means huge force is going to be act for a short interval of time. Sometimes you used to say in your day-to-day life, yeah, the class of that particular teacher is very impactful. Meaning is what? Meaning is that in less time, much more information or important information has been given. That's why you used to say that is impactful. Sometimes you used to say, Virat Kohli or any other, player has been play the impactful inning. What is the meaning of that? Means in the short, in the less ball, they have scored a better. That's the meaning impactful, right? So, especially talk about toughness, right? That play major role when the load is impact in the nature. Means suddenly, like this is my hand, I am going to be hammer. So, if they have less strain energy capability to store the rest strain energy, they will broken down fastly. But they can store more strain energy. Means if I am going to be hammer, they will not going to be broken down. Clear that point? Right. Come to the next. Yes, hardness. In your day-to-day life, you say, yeah, that people is very hard. What is the meaning of that? You used to say, yeah, that is very hard. So what is the meaning of that hardness? Hardness is nothing but, simply we can say, sir, it is that property of material because of which it resists the indentation, penetration or a scratch over it. Suppose if this body is hard, the meaning is that it will be difficult to me to make an indentation, to make a hole over that. It is difficult to making a scratch over that. It is difficult. So hardness is nothing. This is that property of material which gives the resistance against the indentation, against the penetration, against the scratching. That is called hardness. Like you used to soap, right? So soap, soap during the bath you are using soap, shampoo, whatever. Soap is also so soap is very soft because very soft. Why? Because it is easy to scratch over the soap, right? It is easy to penetrate, so it is a very soft, right? Sodium is a very soft metal. Same way, sodium is very soft, right? So hardness is the resistance of metal, a material to indentation, scratching, abrasion or wear. Wear means this is nothing but it is something like a scratch. That is the meaning of wear. It indicates how well material can resist surface damage. Hardness measure using various standardized tests such as Brinell, Rockwell, Beaker hardness test. Material like diamond exhibit extremely hard. Extremely hard is what? Diamond. Now, I will ask, what is extremely soft? What is extremely soft, my dear friends? What is extremely soft? Talc. Always keep in mind. Students used to remember extremely hard is diamond, but they are not going to remember which one is the extremely soft. They may ask. So it will talc is the extremely soft. Hardness is important property. Tool, yes, cutting tool. You have to be cut the metal, right? You might have been seen the grinding wheel. You might have been seen the milling. So if you are going to be cut anything, so during cutting, what is happening, my dear friends? Temperature rises. Because of the temperature, what happening? Hardness decreases. If hardness decreases, तो फिर क्या होगा? That is going to be broken down, right? So if you talk about any cutting tool, that must have sufficient hard so that they can work at a high temperature also without reducing their hardness. And that for that purpose, sometimes I am going to do the LY. This is called red hardness. Red hardness means is what? The material which can sustain their hardness even at a higher temperature. That's the meaning of red hardness. Sometimes you might have been seen that body have good red hardness property. Meaning is that it can capable to bear their hardness, to sustain their hardness even at a higher temperature. That is the meaning of red hardness. So if you talk about tools, machine parts, surface, that all play major. In that all hardness will play a major role. Right here, whatever I have told you, So simple, we can say resistance of material to indentation and scratching abrasion. Wear indicate resistance to surface damage. Here we can say different types of hardness test you are going to be performed. So this is your Brinell hardness test, this is your Rockwell, this is your Beaker hardness test. I will discuss one by one, don't worry. Here we can say high hardness, there we can see the low hardness. Lead is basically soft, diamond is extremely hard, that all are okay. So always keep in mind, hardness means resistance against the scratch, against the penetration, against the indentation, that all comes in the category of that one. Okay. Now brittleness. What do you mean by brittleness, my dear friends? What do you mean by the brittleness? Okay. So brittle, property of material where is fracture suddenly without significant plastic deformation or absorb very little energy before the fracture. You might have seen the glass. Glass is what material? Brittle. Broadly we can convert. You can broadly divide the material in two parts. Either it will be ductile or it will be the brittle. Ductile means any material which is going to be fail minimum 5% dimension change is going to be takes place minimum. Suppose, my dear friends, this is one of the object. A student usually confuse how I can judge body is a ductile or brittle. So let's assume there 100 is 100 mm and 100 mm. I am going to be load, apply the load, and the body has been gone. Now this is 5 mm change. So now total length 105. Now after that, if that body is going to fail, then it will be called ductile. Now suppose this is 100 mm and you are going to apply the load and it is failed here just by 2 mm and that has been failed. So this is called brittle. So what is the meaning? Means if the dimension change is more than 5% before the fracture, then it is called ductile. If the dimension change is less than 5%, after that the fracture has been takes place, or before that fracture has been takes place, that is called brittle. Like way glass you have, so in this dimension change is very less. They will fracture very quickly. They will going to fracture once the load is going to be applied. So that is the meaning of brittleness, right? Simple. So property of material where is fracture suddenly without significant plastic deformation. Here we can see all that. This is a ductile material, but here you can see the brittle material. It is going to be broken down. Okay, now my dear friends, here I am going to be see you. Sometimes they may ask, that is very ductile, this is less ductile, and this is brittle. So we can see in the ductile material, the fracture is of cope and cone. Keep in mind, this is something like a cone. Na? Tell me, na? This is something like cone. So sometimes they will ask, what type of failure occurs in ductile material? Answer will be cope and cone failure. Cope and cone. Keep in mind, why cope and cone, sir? Because something they form like a cone. That's why it is called cope and cone fracture. But in the brittle material, we cannot see anything in cope and cone directly. It is going to fail. Like you have remember in your childhood or remember your college day when there was no digital board, nothing else was there. It was taught with the help of pencil, or it is called chalk. Right? Have you remember that time? You remember your childhood, okay? In the classroom, there was a blackboard and there was some, pencil, or you can say the duster, or it is called chalk. I think duster is something which is going to be the, but chalk it was called, right? So chalk, when you are going to broken chalk, it is going to be broken like that. Why? Because it is a brittle material, sir. This I will broke it. It is a maybe brittle material, so it will fail like that. But it could become, if ductile, then the failure will be something like that. Like you talk about mild steel, yes, that is your ductile material. You talk about low carbon steel, mild medium carbon steel, that all are example of aluminum. We can talk copper, you can talk, that all are the ductile material, and they will fail something like that. Because why it is happening? Because before the failure in the ductile material, dear, there will be the reduction in the what area, and this is called necking phenomena. Necking, this is your neck na yaar. Area become necking means what? Where area is less in whole area, their area is less in your whole body, the area is less there, and it is called neck. Same thing here. If you think about all that, so here the area is less and the broken, and it will be broken from here. That's why deformation takes place after the necking. if you are a mechanical engineer, you might have been listen, okay, now necking has been takes place, now the deformation will come sooner. So why? Once the necking is happening, so it will filter something like that. But in the brittle material, there is not any types of necking phenomena is going to be takes place. Clear that point? And this is less ductile. Okay, now stiffness. So what do you mean by stiffness, my dear friends? What do you mean by stiffness? Have you seen the spring? Yes, sir. I'm engineer. Why you are making a fun with me? I have seen the spring, right? So what? This is your spring, Baba. Helical, right? Okay. So what is stiffness? This is called a spring constant, called stiffness. Whatever you have to be tell. The load required to get unit deflection. In the world, all the body have a stiffness. Even you have a stiffness, I have a stiffness, my marker have a stiffness, my mobile phone have a stiffness. In all the body have in the world, all the body have a stiffness. That is different things. In certain case, it will be high. In certain case, it will be low. But sir, what is a stiffness, sir? Yes, real sir. To get unit deflection in any body. Like way, if this is deflection, change in length. Deflection means Baba, change in length. So we can say if deflection is becoming 1, so can I say if deflection is 1, unity, deflection is unity, so can I say K equal to W? W is what? Load, Baba, load. You are going to apply the load, na? Then their length will change, na? So K is equal to W. So how we can define the stiffness? Simple, we can say, sir, stiffness is indicate amount of load required to get unit deflection in any object. That is called their stiffness. That means, sir, if this is the object and I have to be change their unit length, sir, I have to be change their unit length. Oh, changes, unit length changes. Okay, so I have to change their unit length. So whatever effort I have to be apply, whatever load I have to be apply, that is called stiffness. So stiffness is nothing but amount of load required to get unit deflection in a body is called their stiffness. That's why earlier I have told you, in the world every body have a stiffness. That different things, in certain case it could be high, in certain case it could be less. But yes, all the body have a stiffness. Your mobile phone have also a stiffness, right? So here we can say important, in a structural component where deformation is must to be minimized. Okay, so you want ki deformation should be less, so you have to use the material having high stiffness, so that you have to apply the more load to get the unit deflection. So you need to use the material where you require less deflection, to use that material having high stiffness. Clear that point? Clear? Tell me. So clearly mention, resist deformation under the applied load directly related to the Young's modulus. Yes, right. So all that case. Now I will discuss next concept, and yes, in MCQ I will discuss resilience. Already we have discussed. This is the energy stored up to the elastic limit, right? So what is resilience? Already I have told you, absorb and release energy, elastically deform, energy stored and released under the elastic deformation. Means this is the body. You have applied the load F, they have deformed something like that. This is deformation. So what will be the energy stored? F into dx. Now if I am going to remove the load, or they are going to be recover their original shape, means all the energy has been released. So resilience is what? This is the energy stored by a body up to the elastic limit. And up to the elastic limit, if load is up to the elastic limit, what is happening? Once I remove the load, the body will come to their original shape. That means whatever energy they have absorbed, that all will be released. That's why resilience is releasable. It is recoverable. You can say that recoverable. You can recover that. You have applied this, so they have stored the energy. Once I remove the load, all will be recovered, right? That's why you can see here, ability of material to absorb and release energy when elastically deformed, energy stored and released under elastic deformation. And here I have given some deformation. This is your here, this is elastic point, and this is called your modulus of resilience. Modulus of resilience I will discuss, no need to worry. Meanwhile, just try to understand what is resilience. Now next property I am discuss creep. What is creep, my dear friends? What do you mean by the creep? Anybody can tell me? So creep is nothing but it is a permanent deformation in any object at a constant load over a period of time at an elevated temperature. So various things you have told. Please go slowly. So what is creep, my dear friends? Creep is a deformation in a body at a constant load. Okay, load is constant, sir? Yes, at a constant load over a time or period. Means, sir, it will act for a longer time? Yes, sir. And especially it becomes significant when the temperature will be high. Let's try to understand through one example. In your room, there is a ceiling fan? Yes or no? You can say, no, sir, in my room, no, sir, I am completely in the AC, sir. Okay, let's assume in your room, there is a ceiling fan. So, you know, this is your ceiling fan like that. And this is your room and this is your ceiling fan. I cannot draw exactly the ceiling fan, but let's assume this is something like that. Okay, here it is ceiling fan. So now what do, my dear friends? You know what is the load acting? You can say weight of the ceiling fan is there, mg. Yes, sir. Now do one thing. Today take what is the length of that fan. Take length, measure the length of the fan today. Today you have measured. Okay, you have measured. Let's say you have measured. Now come after 2 to 3 years. How many years? 2 to 3 years. 2 to 3 years. Load is constant, Baba. That is only load is there is going to be act. No any other load is there. It is constant load. Now repeat the same thing. Now measure the length. If you know you will measure the length, it will be little bit significant high. That will be in the millimeter, micron. Even you cannot see through the naked eye. You have to use the proper instrument to check their change in change in length. And that increase in length, Baba, this is called creep. And it becomes more severe if the temperature of room will be high. Whatever you length you can see, if the temperature will be high, it will become something like that. It will become higher. So creep becomes very significant, very dangerous at a high temperature. So once recall again, what is the creep? So creep is a, sir, permanent deformation, okay, sir, at a constant load, because load is constant. And this creep is happening over a period of time, sir. I am not telling you just check after 2 minutes. No, I am not telling like that. I have told you check after 2 to 3 years. Certain case it could be 2 to 3 months. Certain case it could be 2 to 3 weeks. That depends upon totally what the temperature is there. So, and we can say creep is a time dependent permanent deformation of a material under constant stress, usually at an elevated temperature, right? Even when the applied stress is below the yield strength, material can slowly deform over a time due to creep. This phenomenon is critical in component operating at a high temperature. As I told you, at the high temperature, creep becomes more significant, right? Such as, especially you talk about turbine blade and you talk about the steam turbine blade, which is working at a high temperature, right? Turbine blade, boiler, engine, engines. Creep occur in 3 stages: primary, secondary, and tertiary. That I will discuss. Okay, but just keep in mind it will be in the 3 stages: primary stage, secondary stage, and tertiary. 3 stages there in the creep. And mostly we can, once the tertiary stage is completed, after that failure can take place. So you have only option in the secondary stage to recover that. Here you can see diagram clearly visible to all of you. This is your creep, Baba. Time dependent permanent deformation of a material under constant stress, usually at a elevated temperature, clearly mentioned there, right? Occur even the stress below the yield point, even load is below the yield point, still will get the permanent deformation in that. But yes, over a time period, over a long period of time. Now next is fatigue. You used to, if you have remember, my dear friends, in the college day or even if you are in the working, so sometimes you used to say one word, yeah, today I am feeling fatigue, right? You used to say or no? You used to say, na, yeah, today I am in the fatigue. Can you tell me what is the meaning of that fatigue? Means, sir, today something is happened that usually not happening, sir. Today something is happening that usually not happening. That's why you used to say I am fatigue. So meaning is that, so something is changes with time, right? Usually you are working in 8 hours. And I will tell you, no, from tomorrow you have to work at least 20, not 20 will be very hard. Let's assume 14 hours you have to work daily. Yes, we'll get, oh, sir, I'm very fatigued, sir. You will get. Why? So what is the meaning of fatigue? Fatigue is nothing but, in that case, the magnitude of load either changes with respect to time or even by magnitude. You know, load is a vector quantity. So they have two things. One is magnitude, another one is what? Direction. You know, force is a vector quantity, na baba? Force is a vector quantity. You are going to apply the force. So it can have two types, magnitude and direction. So force can be changed by two ways. Either I will change the magnitude or I will change the direction. So what is fatigue load? Fatigue load is that load, sir, in which the magnitude of load or either direction of load changes with respect to time. That is called fatigue load. And if you talk about in actual day-to-day life, load is a fatigue. You know, if you talk about bus, you have to design the bus. Which type of load is there? Obviously fatigue. On the bus, sometimes 20 people could be there, sometimes 10 people could be there, sometimes 100 people could be there. So there is a fatigue load is there. If you talk about your bike, sometimes you are only going to be drive. Sometimes two people will sit behind you. Sometimes three people can sit. So load is fatigue. Sometimes you are driving your bike and sudden bump is coming over the road. Yes, there is a shock load. Even it will consider as a fatigue load. Comes under the category of fatigue load. So what is a fatigue load, sir? Fatigue load is a material due to repeated or cyclic loading even when the stress level are below the material ultimate strength. Over time, a small crack developed and propagate. Eventually, loading is sudden failure. Fatigue is major concern component like aircraft wings, bridge, rotating machinery. In all that case, fatigue becomes more significant, right? And material will fail very fast compared to their static load. What is a static load? This board is a static load for this wall. This is my digital board, na? So this is like a static load. Why? Because this load is fixed. It is not going to be changed over a time. Even their magnitude is fixed, direction is all things is fixed. It is not going to be changed over the time, sir. So that is a static load. And a static load is not a savior, right? But fatigue is a savior. How the fatigue crack, crack is propagate. Yes, I will discuss all that very details in the class. Already we have discussed. If you purchase that batch, in which you will get the already that I have told you, material science already have completed in Andhra Pradesh AEE batch. So once you purchase that batch, suddenly you will get the what we can say. Suddenly you will get the access of that recording course also. All the thing here, very details we have discussed. So in the fatigue load, what is happening actually? One crack is going to one crack is going to be formed, and once the crack is formed, the crack have very danger thing. They will always propagate. And once let's assume this is your object, and here crack is formed, and once the crack has been formed, now it will propagate one end to another end, and ultimately your body is going to fracture. So that is a very major concern, the fatigue load, especially when the crack is formed, the life will decreases. And one thing is called a short pinning. To the short pinning, we can reduce the movement of crack, and the life will may increase. Okay, so that is your impact strength. As already discussed, material resists sudden or high rate of loading or shock. Impact strength is the ability of material to resist sudden and high rate of loading or shock. It indicates how much energy material can absorb during rapid load application before the fracturing. This property measuring using, I will discuss what the different types of tests for that we can measure all that. Now my dear friends, discuss about so that is simple. We can say impact load. Now baba, this is the material on that, this is coming and going to be hammered at. So this will be called impact load. In a less time, hinge force is going to be act. So here we can say this impact force, this gada is going to be come and going to strike on that object. So this is called what? Impact. Aircraft wings, bridge, rotating machinery, that all are under the category of that. So that is all about the different property, my dear friends, which is important to us. We have discussed all the important property. Now I will discuss how I can measure the testing of these types of material. So now I will discuss, that was the first part, property of material. Now I will discuss testing of materials, right? So basically if you talk about, so there are two types of testing. How many types? Two types. One is destructive testing, another one is NDT, non-destructive testing, right? Yes, my dear friends. So now we will discuss next concept, that is what? Testing of material. Already we have discussed about the property of material, right? Now I have to be checked, okay, what is the desired property, is there or not, and what is their magnitude, like that I have to be checked, right? We have discussed hardness, we have discussed, ductility, we have discussed about the toughness. So all that property you have to measure. Okay, so there's a different approach by which you can measure that property. That's what is called, testing of material. Okay, here we can say, if you talk about testing of material, broadly it can be divided into two parts, right? One is called conventional testing method. This is also known as destructive testing, and another one is called non-destructive testing, or called non-conventional testing machining. So basically there are two type of testing method. One is conventional, another one is non-conventional. Conventional is also known as, you can say, destructive testing, and non-conventional is also known as what? Non-destructive testing. This is also called NDT. So first let's discuss about the conventional method, that is destructive testing. What is the meaning of destructive, my dear friends? This method involves the permanent damage or failure of the specimen to determine the material property. Suppose you have to measure the hardness of that material, right, through the conventional method, that means destructive testing. So if you measure the hardness of that material, let's assume you have a mild steel, or let's assume low carbon steel you have. So you have taken one specimen to perform the test to get the what is toughness, what is ductility, what is hardness, whatever. So once you perform the operation on that specimen, after the you can say what operation, that body cannot be used for any other application because it will be destroyed. That is the meaning of destructive testing. If you talk about NDT, in the NDT what is happening, you have performed the test on that specimen. After the application of that test, you can use that for another application also. It is not going to be destroyed, but in the destructive it will be destroyed totally. So here we can say this method involves the permanent damage failure of the specimen to determine the material property. Like first you have to discuss about the hardness testing method. So hardness testing determines the resistance of material. Already you have discussed hardness is what? It is resistance of material about the indentation, penetration, surface scratch, all that, right? So first here we can see Brinell hardness test. Just keep in mind, Brinell hardness test basically going to measure the hardness of the material. This method, hardened steel or carbide board is pressed into the material under heavy load. Only these things you have to keep in mind. In the Brinell hardness test, a hardened steel or carbide ball placed into the material under the heavy load. We can see there. This is the here, and you are going to be press them, and according to that will get the what is the indentation, right? The diameter of the indentation formed is measured and the hardness is calculated. It is suitable for soft to medium hardness material like cast iron and non-ferrous material. For that you can use that. Here we can see it is happening something like that. You are going to press, you are going to apply, and on the basis of that indentation you could be able to measure what is the hardness of that particular material. Second one is what? Rockwell hardness test. This test measure hardness based on the depth of penetration of indenter under the minor and major load. So that thing you have to keep in mind. They are going to ask in which of the following method major and minor load is applied to check the hardness. Then it will be what, my dear friends? It will be the Rockwell hardness test, right? And yes, different test scale is there, diamond, cone, and all that. So mainly you have to be keep in mind. Okay, it is fast and widely used in the industry. Rockwell test mostly going to use in the hardness, steel. It is something like that. This is minor load, diamond indenter is there. That question is also going to ask in which case diamond indenter is used to get the hardness. It will be the Rockwell hardness test. So this is, and after that you have applied the load, and it is becoming something like that, minor load here, and after that by that indentation will get what is the hardness. Here also we can see in that diagram also I have given. Here we can see now minor load is there, right? Then it have indented that. Now after that you have applied the major load, and after that calculate the distance between minor and major load, and after that you could be able to judge what is the hardness of the material. Like, okay. So next you talk about, this is called Beaker hardness test. So what the important thing about the Beaker hardness test? The diamond pyramid indenter used and the diagonal length of the indentation is measured. Diagonal length here you have to measure. It is highly accurate, suitable for both hard and soft material. Beaker hardness test is suitable for both type of material to get their hardness, either it is hard or soft. In both that you can use that method, including even you have a thin sheet also. You can get the hardness of thin sheet by the help of Beaker hardness test. That thing is going to ask you which of the following method is suitable for the measuring the hardness of thin sheet. Then it will be the Beaker hardness test, right? Noob hardness test. So this is similar to beaker but uses elongated diamond indenter. This is similar to basically beaker hardness test, but only difference is that it is going to use the elongated diamond, right, indenter, making suitable for very thin material and coating. It will be something like that. Okay. Next is what? Sore hardness test. That all are the method of hardness test. This test measure the hardness based on the rebound height of hammer dropped onto the material. That thing is also going to ask what is sore hardness test, and in which test I am going to measure the hardness on the basis of rebounds back. So it will be the sore hardness test. Keep in mind that is the important point. Rebounds height of hammer dropped onto the material. It is mainly used for rubber and soft material. Generally, you are going to use the sore hardness test. Now you talk about toughness. So for the toughness measures the ability method to absorb the energy before the fracture. Already you have discussed about the toughness. So basically you have two methods to check their toughness. Right here we can see this is your toughness. They are going to store the energy before the fracture. This test evaluate the material resistance, crack propagation. It is critical design against the brittle fracture, especially pressure vessel and aircraft that play the major role. Now you talk about the impact testing method. What is the impact testing? Keep in the mind the approach which is going to use. One is called CHARP test. Simply they are going to ask in the exam which of the following approach is going to use the impact testing. One option will be there CHARP hardness test, CHARP impact test. Another could be Brinell hardness, another could be like that sword test, like that some option will be given there. Then you have to be answer. So in this, what is happening in this method? The notch specimen is struck by a pendulum hammer and the energy is absorbed. It is something like that. During a fracture is measured, this specimen is supported at both ends and notch is placed opposite to the impact point, and it will become something like this. Is the material where impact extent to have to measure something. This will come and strike on that, and accordingly we will get the result. Okay. Impact energy absorbed breaking by the material before the breaking, right, can be calculated by E1 and E2. Simple test is there. Next is called ISO test. So similar to CHARP test, but the specimen is held vertically like cantilever beam. That is only keyword. In the ISO test, a specimen is held vertically like a cantilever beam. That thing you have to be keep in mind, right? The notch faces the hammer and energy absorbed is measured. Now you talk about non-destructive testing, that is NDT. This is basically in the why it is called non-destructive testing. These methods do not damage the material and used for detecting defect and ensuring the quality. In this, your specimen is not going to be damaged. It can be used. Your specimen just you are going to be defect, ensuring the defect, and after that it can be reused. No problem is there. That's why it is called non-destructive testing, right? Here we can say surface crack detention method. So basically one is called surface crack you have to measure. One is what? Visual inspection. So that is a very simplest method, means by the visually you can analyze is there crack or not over the surface. So the simplest method where the surface is visually examined using the naked eye or magnifying device. It is quick but limited to visual defect only. If the surface defect is macroscopic in the nature, you cannot perform the visualizing test there. Next is what? Dye penetration test. This is called DPT, right? Dye penetration test. So how it is happening? Here we can say a liquid dye is applied to the surface, okay, while penetrate surface crack due to capillary action, and after cleaning, developer applied and making the crack visible. It widely used for detecting the fine surface crack. Man, what you have to be keep in mind, my defense. Suppose this is one of the surface, and you have to be detect the surface any crack over the surface. So put the dye. If dye is going to be inserted on by the capillary action, after that you can magnify them and you can clearly round that. Okay, there is some surface crack is there. So that is simple things. So a liquid dye is applied to the surface which penetrates surface crack due to the capillary action. That thing is also going to ask in the dye penetration test how liquid is going by. capillary action and some option could be there like diffusion effect, capillary, something like that option would be there. So you have to be answer. Next is called magnetic particle testing MPT, used for ferromagnetic material. This method involves magnetizing the component and applying the magnetic property. This particle accumulate and leakage point cause crack, making them visible. Simple. Now I am going to talk about the internal crack. Whatever that was, basically they are going to find the crack over the surface. Now suppose if any defect inside the material, then what you can do? So in that case, first you can see the ultrasonic. Here we can see the ultrasonic testing. So here what is happening in the ultrasonic testing? High frequency sound wave are transmitted into the material. Reflected wave from the internal flaw are analyzed to detect crack, void or inclusion. It highly accurate and widely used. My dear friends, suppose you have to measure the surface crack, surface internal crack basically. So it is something like that. You are going to be give the ultrasound, means sound having frequency approximate 20 kilohertz to 40 kilohertz. 20 kilohertz means 20,000 hertz to 40,000 hertz. And after that they will go, and there any defect will be there, it will be rebound back, and after that we will get the signal, and accordingly you could be able to judge either it is any crack or not. So here also we can see this is actually that they are going to perform to get the we can see the crack inside the material that way. So simple thing is there. So always keep in mind ultrasonic ultrasonic testing basically going to perform to get the internal defect basically, which is inside the structure, like that. Okay. Next is what? Radiographic testing. Radiographic, yes, some rays will be given there. So X-rays or gamma rays are passed through the material, and the variation is absorption is captured on a film detector. Internal defects such as crack, porosity, inclusion can be measured. Here, see, my dear friends, this is one of the material over which you have given the rays, gamma rays, X-rays, etc. This rays is coming, and there is one defect inside the material. One thin film will be there. On that film, their whole image will form, and whenever defect will be there, that will be shown like that. So that is a simple technique by which you could be able to judge okay, there defect or not, if there is defect present or not. So simply X-rays, gamma rays, they are going to be, and their image is going to be taken out one of the film. On that image clearly it will be visible either there is a crack or not. So see here, there is a crack, so totally here it is going to be inspected image is there and detected film is there. On the detection film, inspected image will come, and you could be able to analyze okay, there is a roughness or not, a crack or not. Next thing is what? Eddy current testing. What is this? This method use electromagnetic induction to detect surface and near surface defect in conductive material. Variation included current indicate flow, something like that. It is coming here like now. And if any defect will be there, if no defect, eddy current from flow normally like that, or no defect, with defect it will start flowing like that, and after that you could be able to judge okay, if there is any distortion in the current, by that you could be able to visualize okay, some problem is or not. Next is called aquatic emission testing, AET, aquatic emission testing. So what is this? This technique detects sound wave emitted from the material. Under state, it help identify the crack initiation and growth in a real time. That thing you have to be just keep in mind. It is something like that, my dear friends. We can say aquatic testing, emission testing, simple. Okay, here amplify some defect is there, you can observe that. So I will share that PDF, no need to worry. Okay, so my dear friends, now I will see okay, how many different concepts we have learned. So let's start some question. I have 50 questions. Randomly I will solve some question, and you have to be answer that question. Question number first: which property of material define ability to withstand applied load without failure? So what will be that? I think every one of you can answer. What will be this? Toughness, strength, elasticity, or hardness? Yes, it will be the strength. Property of material define ability to withstand applied load without failure. It will be what? Strength will be the answer. Okay, that is the next question. So you can say which of the following example of material is strong in compression? Rubber, copper, concrete, or aluminum? Yes, a column you are going to be made with the help of concrete, and you know the material which is brittle in the nature generally strong in the compression. So correct answer will be the concrete, and hopefully you have given the answer. Even in the column you have to be seen concrete is going to be used because they are strong in the compression. Generally, all the brittle material, mostly brittle material are compressive in the nature, have more stronger in the compression, we can say like that. Okay, come to the next question. Elasticity is the property by which material breaks suddenly under load, permanently change shape, return to original shape after the load removal, absorb impact energy only. What will be answer? Now, I think you have given the answer. Given answer is what? C for Chennai. Return to original shape after load is removal, right? So that will be answer. Come to question number next. So all that you have to be solved. Hooke's law applicable only within the which limit? It is Hooke's law is stress is proportional to strain, right? But that is applicable within the proportional limit. But since in the proportional limit is not there, in that case I am going to prefer the elastic limit. But generally it will applicable only to the proportional limit. But gap between elastic and proportional is less, so sometimes you can go to the elastic limit also. Right, here we can say proportional to strain, but this relation hold within the elastic limit. Beyond point that cannot hold. After that, this is not capable to hold. The measure of elasticity of material is given by how you are going to measure hardness number, toughness, Young's modulus, or endurance limit. Yes, the elasticity basically going to be measure material given by the Young's modulus. Yes, plasticity is the ability of material. What is the plasticity? Is the ability of material recover completely after deformation? No sir. Undergo permanent deformation without rupture, resist indentation, resist repeated loading. Yes, before Bombay is the right answer. Undergo permanent deformation without rupture is the right answer, and hopefully all of you have also given the correct answer of that question. Come to next question. Which property allow material to be drawn into wire? Already you have discussed ductility. Can you tell me in the word which material is the highest ductile? Yes, gold is the highest ductile material. I think you have remember if you have watched all the lectures. Ductility is commonly measured in terms of rebound height, percentage elongation, Brenner number, yield ratio. Yes, it is in the percentage elongation you are going to measure. Already you have discussed about that. All the question you have discussed. Question number 9th. Which property allow material to be hammered or roll into the thin sheet? You have to be convert the material in the form of thin sheet. So which property is responsible for that? You have some option like ductility, malleability, resilience, or toughness. So yes, what will be the correct answer? It will be the malleability will be the right answer. Okay. Okay. Question number next. Which one of the following material is highly malleable? Which one of the following is highest malleable? Gold is highest ductile as well as highest malleable, right? So correct answer will be the gold will be the right answer of that question. Question number 11. Toughness is best described by the ability of material to resist scratching only, absorb energy before fracture, resist deformation only within the elastic limit, resist corrosion. So what will be the correct answer? Absorb energy before the fracture. That is called your what? That is called your toughness. Right. Come to the question number 12. Which of the following is considered as a tough material? Which one? Glass, ceramic, mild steel, cast iron. Which one will be the correct answer of that? Toughness means they are going to absorb the more energy before the fracture, right? So can you tell me, if you think about glass, this is a brittle material. You think about ceramic, brittle, cast iron, brittle. But dear, if you think about option number D, C, mild steel is what? Ductile, so it can be capable to store more energy, right? Yes. So question number 13 on your screen. C for Chennai is the right answer. Hardness is the resistance of material to everyone can answer. Indentation, scratching, and wear. It is a resistance against the scratching, indentation or wear. That all are. Question number 14. Which material have extremely high hardness? Rubber, red rubber, diamond. So yes, diamond. Now comment. Which material is extremely soft? I have told you just in the theory part. Talc is one of the material which is very soft in the nature, and diamond is just the opposite. It is hardest material and it is the softest material. So they may ask, which one is hardest, which one is softest. So try to remember that. Okay, question number 15 on your screen. What is question number 15? A brittle material generally show large plastic deformation before breaking. Fracture suddenly without significant deformation. Yes, fracture suddenly without any significant deformation. So B for Bombay is the right answer. Question number 16. Which of the following is brittle material? Copper, aluminum, glass or mild steel? Glass will be the brittle material. Simple, right? This is the next question. Stiffness of material directly related to density, Young's modulus, hardness number, impact value. So what will be the stiffness? Higher the stiffness, what will be answer of that? Question number 17 on your screen. Stiffness directly related to its Young's modulus, na? So B for Bombay is the right answer of that question. Already you have discussed all that. Question number 18. Which material is stiffer? Rubber, wax, steel or lead? So okay, their answer is given here. Chennai. Steel will be the more stiffer. Stiffer is what? Load required to get unit deflection. That is stiffness, na? Load required to get unit deflection is called stiffness. Resilience is the ability of material to resist indentation, absorb energy in elastic range or release it on unloading, deform permanently, resist creep at high temperatures. What will be resilience? Absorb energy in the elastic range and release when it is unloading. So yes, B for Bombay is the right answer. Okay. Come to the question number 20 on your screen. Material used for spring should have high what? It must be high resilience, right? Then only spring will be good. Now they have my resilience is what? They are going to store the energy. Like suppose this is a spring. If load is coming, they will store the energy. Once load is going out, load is going to be removed, they will release the energy. Then all it will be good spring. Now, so yes, they should have high resilience so that when load is acting, they will absorb the energy, and when load is removed, they will release the energy and come to the original shape. Okay, question number 21st on your screen. Creep is most significant when material is subjected to sudden shock at room temperature, constant stress at elevated temperature, repeated cyclic loading at low temperature, compressive stress at for a short time. What will be? Constant stress at elevated temperature. In that case, creep becomes most significant. Right? Already you have discussed everything about that in the theory part. Okay. Yes, question number 22 on your screen. Which of the following component is most likely to fail by creep? Creep is what? It is becomes significant at the high temperature, right? Na? High temperature it becomes more significant. So tell me, which one of the following is working at a high temperature? Glass bottle, wooden rubber, hand file, turbine blade. Yes, it will be the turbine blade. When load is also, stress is also there, temperature could be there. So because of that, it becomes more significant in that case. Right? So I think all of you have given the answer. The second stage of creep known as the stage of what second stage? See, have you remember? Forget creep now. Here I am going to see you the diagram, whatever the concept you have discussed. Creep, right? See here. Creep is there, right? So here we can say the secondary is constant rate, right? In this you can get the constant rate. So what will be answer of that question? Constant creep rate, right? Second may you will get the constant creep rate. Primary and tertiary it will be the high. Question number 24. Fatigue failure is due to a single statics, heavy statics load only, repeated or cyclic load. Yes, fatigue is basically what? Repeated and cyclic load. Clearly we can see there. If you talk about here, see, material due to the repeated or cyclic loading, right? Everything is mentioned. So read the PDF, you could be able to answer all the question, right? repeated and cyclic loading. Even that type of question we can expect in your exam also directly from that topic. Okay. Next, which of the following is a major concern for fatigue load? Bridge member under repeated traffic load, concrete block stored in a yard, gold seat in decoration, wooden pattern in foundry. Which of the following is a major concern for fatigue failure? Anybody can tell me? Yes, it will be the bridge member under repeated traffic load. Okay, bridge member under repeated traffic load will be the right answer, because load is going to be changed. Yeah, sometimes 10 bus will be there, sometimes only one bus would be there, like that. No, simply you could be say about that. The fatigue behavior of material represented by, yes, it is represented by ascent curve, stress or number of cycle curve. Basically already you have discussed all that, na? So my dear friends, that all about the session. Now as you purchase here everything, all that I will share the PDF, don't worry. So my dear friends, as I told you, your syllabus is same with Andhra Pradesh, right? AEE. So our batch is going on. Telangana AEE having 19 seat is there, 19. So you can ace your preparation with us. As you purchase the module, suddenly you will get the access of the previously recorded batch. Even I will come again and then we'll discuss. Okay. So thank you all, and yes. Good.